Morning, good afternoon, good evening, whatever time it is where you are. Today I'm going to be talking about Boyle's Law. If you remember from the last video, I had introduced the concepts of three different gas laws. The first gas law I talked about was Boyle's Law, the second was Charles' Law, and the third was the combined gas law. We're going to address each one of those different laws independently of one another. The best one to start with, because it's the simplest of all the laws, I feel, is Boyle's Law. So that's what I'm going to talk about today in this video. And if you guys take a look at the notes that you have in front of you, you can follow along and fill in the answers there as we go. And I talk a little bit about Boyle's Law and show you how to use Boyle's Law equation to solve some word problems, okay? So again, Boyle's Law is a useful tool for describing how volume and pressure interact with one another in a confined gas. So in other words, when I say a confined gas, I'm speaking about a gas that's held in some sort of container where it can't escape, like a propane tank or a tire, something like that. So let's talk about Boyle's Law. The first question I have up here on the board and on your papers, guys, it says, how does volume change? So that's a kind of a straightforward general sort of question there. So when they're talking about volume here, the volume of a gas will increase if the pressure decreases, and the volume of a gas will decrease if the pressure increases. So let's go ahead and write that down. If I can find my chalk, the case of the missing chalk here. So if pressure increases, volume decreases. And guys, this is something that you're probably already familiar with and don't even realize that you know something about. I know as a young child you probably at some point had a balloon and you played with that balloon, squeezing it down, the balloon got smaller. So in other words, you increase the pressure on the balloon decreases in size, therefore its volume must have gone down. So there's not any groundbreaking discoveries there, but it's described using Boyle's Law. So let's go ahead and write the inverse of that. So if pressure decreases, then volume does the inverse. Then volume increases. Again, no amazing discovery there. Later on, when we talk about the Charles Law and the combined gas law, you find out that it's not just as simple with gases as describing what happens when their pressure decreases or the volume increases. Instead, you have to take into account the temperature that gas is being held at, or the temperature that changes over time, and how that has an impact on both the pressure and the volume of a gas. Okay, so sorry to give you a chance to copy that down. If you haven't gotten it down, make sure it's down in your notes, please, guys. You're going to show those to me once we get through getting the notes down and you've got some of these equations solved. So number 2 says, how does pressure change? Well, pressure behaves inversely to volume. So if volume decreases, then pressure increases, right? I mean, this is not, like I said, this is not rocket science, but it was described by Sir Boyle back in the I think it was the late 1800s. Don't quote me on that. I may be off on that, but at the time it was no one had yet described the relationship between pressure and volume and mathematically. They had a very basic understanding of how the gases interacted as pressure and volume changed. He was the first person to actually sit down and find that relationship and describe it with math, and that's really useful for a lot of different reasons. So number 3 says, what's the relationship? Oh, well, actually, let's step back to 2 again, and we're going to describe how pressure changes as volume changes one more time here. So what happens if the inverse happens? So if volume increases, pressure, you guessed it, decreases. So what's important to recognize about this is that the assumption is that the temperature is held steady because, like I said before, the temperature has a direct impact on the volume, and if temperature has an impact on volume, then it also must have an impact on pressure. And when we get to the combined gas law, once we get through Charles' law and we see the relationship between volume and temperature, and then we get to the combined gas law, we'll see that all 3 of them work in synergy to change how a gas behaves. So number 3 says, what's the relationship? Guys, it's an inverse relationship. Inverse relationship. One goes up, the other goes down. One goes down, the other goes up. So an example of that, and I'm giving you one here, one you can't use in your notes, would be the more miles you drive, the less gas you have left. So assuming you just have 1 tank of gas, if you drive 100 miles, you've used half of it, so the miles driven goes up, the quantity of gas goes down. So I'll write that in here for an example. You're going to have to find your own example. If you have to Google one because they're a little tricky, you're more than welcome to. Or DuckDuckGo at my favorite search engine. So an example, drive. So if I drive 100 miles, then my quantity of gas decreases. So one goes up, the other goes down. Driving from 0 to 100 miles, assuming I started with a full tank of gas, then obviously I'm going to have less gas when I'm done that 100 miles than I did when I started. So if the miles went up, the gas went down. All right? So those are those pieces. Now we're going to talk a little bit about, one, what the variables are in Boyle's law, and 2, how to solve a problem or 2 for Boyle's law. All right? So it's going to take me a second to write this question out. You should have this question in your notes. Actually, we're not quite there yet. First, we have to talk about what Boyle's law's variables stand for. So, Boyle's law, as presented in your notes last time you watched one of my videos, is the pressure 1 multiplied by the volume 1 equals the pressure 2 multiplied by the volume 2. Simple algebraic expression. So this is pressure initial. So what pressure it started at. This is volume initial. What volume this started at. Okay, I'm going to stop there for a second while you copy that down. So the initial pressure could be given in pascals or kilopascals or atmospheres or torr or millimeters of mercury. There's I think there was 5 different types of pressure or measurements of pressure that we talked about in the last video. Volume is something we covered fairly extensively at the beginning of the school year. So volume, you'll see it usually in milliliters or liters, could be in kiloliters. So just a variety of different ways of expressing volume. Could be in gallons or quarts or whatever it is. What's important to recognize is that whatever whatever you start solving the equation with, if you start solving the equation with ATMs and liters, make sure that you're winding up with the same units. If we have different units, then, well, more or less we'll get the wrong, not more or less, we will get the wrong answer. All right, so you might have guessed already that P2 is pressure 2. So sometimes when you're solving these equations, you'll find out that they tell you what the pressure became, and they want to know what the initial pressure was from that, or they'll tell you what the final volume was, and they'll want the initial volume or the initial pressure for that. These are always going to be only one variable to solve for, so that's pretty straightforward. We'll look at that in a second. And by now, if you've been following along closely and not skipping through video, you'll probably have guessed that the volume subscript 2 is volume 2. Okay? So those are the different variables for Boyle's law. And now I'm going to write out one problem. I'll go through that problem, and as you probably have recognized already after you flip through your notes, there's a series of Boyle's law problems for you guys to solve before your notes are considered completed and brought to me for review. Okay, so let me go ahead and erase at least what the variables are for, and then I'll go ahead and write out our problem and then solve it. So just make sure I got my calculator here with me. Anyway, here's our problem. 8 liters of propane is held at 3 atmospheres. What is the new volume if pressure is 0.3 atmospheres? Okay, so looking at this problem, if you understand the inverse relationship in Boyle's law, you would recognize that since the pressure went from 3 atmospheres to 0.3 atmospheres, then the volume has to go up. So understanding that inverse relationship is a big part of solving these problems, because if you happen to make a mistake in your math and you go back and look at your math problem, if your math problem isn't adding up with how Boyle's law works, there's a really good chance that you did it wrong. In fact, there's a 100% chance that that would have been calculated wrong. All right, so we have the problem down, and I'm going to start off by identifying all the variables I have. I got 8 liters, that's my volume. I got 3 atmospheres, that's my initial pressure. And my final pressure, or my new pressure, is 0.3 atmospheres, okay? So we're going to use those 3 variables and Boyle's law equation to solve this mystery, right? So I'm just going to slide the camera down a little bit to give myself some more room. All right, so I'm going to start off by saying pressure 1 equals 3 atmospheres. Volume 1 equals 8 liters. And then for the final values, I'm going to see pressure 2 equals 0.3 atmospheres. And our volume 2 is the unknown. It says, what is the new volume? So that's our unknown. So it's going to be volume 2 equals X. Okay, I mean, you can leave it as V if you want. Obviously, the letter doesn't matter. I've always used X for some reason. I don't know why. But we're going to go ahead and solve this problem then. Now, I'm going to erase this bottom part here just to give us a little bit more room so it's a little clearer as I work through this. Actually, no. I'm going to erase the top part just so that we can see what our variables are while we do our solving here. Okay? So, I'm going to begin to write out my equation. My initial pressure was 3 atmospheres, or P1 was 3 ATM. P1, 3 ATM. And I'm going to multiply that by my V1, my initial volume, which was 8 liters. 8 liters. Set that equal to my pressure 2. That was something that was given. It's 0.3 atmospheres. And my volume 2 is going to be X. So it's times X. So let's go ahead through and solve this simple algebraic expression. I'm going to get rid of these so we give ourselves some space. So we get 3 atmospheres times 8 liters. So 3 times 8 is 24. And then since I'm multiplying the two numbers together, you're actually also multiplying its units of measure. So I'm going to get 24 atmospheres times liters. Okay? Set that equal to the other side. 0.3 atmospheres times X. 3 atmospheres times X. And then, just as you probably have figured out already, you need to divide both sides by the number with the unknown variable next to it. So that's what I'm going to do now. So I'm going to divide this side by 0.3 atmospheres to get X by itself. So as you can see from here, that's going to cancel out on that side. I'm going to do the same on the other side. So 0.3 atmospheres. And what's nice about this, guys, if you stop and look, I have an atmosphere in the numerator and an atmosphere in the denominator. When that happens, they're inverse from one another. I have an atmosphere in the numerator and denominator. That means I can cancel them out because they're the same unit. So that cancels out. But what doesn't cancel out is the liters. And remember, I'm solving for volume, so volume should be expressed with that letter L next to it, the liter next to it. So then I'm going to grab my calculator, and I'm going to say 24 liters divided by 24 liters. Wow, this calculator's acting up on me, guys. 24 liters divided by 0.3 gives me 80. So I got an answer of 80 here. So that volume, so we're going to say X equals 80 liters. Right, I was left over with liters. That volume shot up. Our volume got a lot bigger. Does that make sense? Well, 100%. The initial pressure was at 3 atmospheres. The final pressure was at 0.3 atmospheres, right? So you get a 10-fold increase in the volume for that. The volume should have gotten bigger, not smaller in this case. So then, as a good student, you circle for engineer or chemist or whatever you are going to be, or whoever you're going to be, or carpenter, it doesn't matter. If you're doing your calculations at the end so no one gets confused about what you did, you go ahead and you circle your answer, include the correct unit so people know what you're talking about. Okay? So that's our answer. Our answer is 80 liters. Now, to be clear, you can do the same exact equation for any one of the 4 variables here. It doesn't matter which one pops up. So I think they're pretty straightforward. I'm going to call it quits on this video right now, guys. So you can go ahead and work on the rest of your notes there. And when you're finished, or if you need help, just give a yell. I'll be by to help you. See you later.